Chapter 4, Quadratic Functions and Factoring. Section 4.1, Graphing Quadratic Functions in Standard Form. And after standard form, there's going to be two more forms that we're going to be graphing in. So first of all, what exactly is a quadratic function? Well, it's a function that can be written in the standard form of y equals ax squared plus bx plus c. So basically up until now we've just dealt with linear functions which have had no exponents. And now we're going to deal with the highest exponent of 2. And so if the highest exponent is 2, it is a quadratic function. And the graph of any quadratic function is called a parabola. And in this chapter we're going to be dealing with only parabolas that open up and down. In the second half of this class we'll be dealing with parabolas that open side to side. And the vertex is going to be the highest or lowest point on the parabola. So again, if it opens up, it's obviously going to have a lowest point. And if it opens down, it's going to obviously have a highest point. And the next important aspect of a parabola is the axis of symmetry. And the axis of symmetry is, if you remember what symmetry is from geometry, it's the vertical line that divides the parabola into two symmetric or even halves. So it's going to be that line that always is going to go down through the vertex. It's always in this chapter going to be a vertical line. And so what we have graphed here also is the parent function of a quadratic of f of x equals x squared, which again is the same thing as y equals x squared. And so now let's take a look at some basic parabolas. Given y equals ax squared plus bx plus c, let's take a look at what effect the a has on the coefficient, or has on the graph. So in other words, the coefficient of the squared term. So to begin with, I have graphed here in red the parent function that I just had on the previous screen, which you have above in your note packet. And remember, when you're graphing anything that's unfamiliar or that you don't remember how to graph it, you should always make a t-chart. And remember, because of things like squareds or other exponents or absolute value, you should always also make sure that you pick positive and negative values. So here I'm going to graph the graph of 1/2 x squared. And now again, picking positive and negative numbers to graph y equals 2x squared in the bright blue. And now in the purple, graphing negative x squared, and remembering that the negative x squared is like negative 1 times x squared. So that negative in the function does not get squared, and so that's the purple graph. And so now what effect does the coefficient of x squared have on the graph? And there's a spot in your note packet, and I would like you to write that down, and we will be discussing this in class. And so now let's sum some of this stuff up. The quadratic function has the standard form of ax squared plus bx plus c, remembering that the a can't be equal to 0 because if it did we wouldn't have a squared term, and so we would just have a linear function. And the graph formed by the function is U-shaped, and it's called a parabola. And now we're going to jump down to the vertex is the lowest or highest point on the graph, depending on whether it opens up or down, and its x-coordinate is opposite b over 2a. And so this is an important thing that we're going to be seeing in the next slide. So we're going to come back to that. But this is also the axis of symmetry. And then of lesser consequence is the fact that the y-intercept is c. So the point 0, c is also on the parabola. So now let's go through the steps of graphing the quadratic function. And on that last slide, I'd like you to try to fill in those blanks, but we will be going over that in class as well. Graphing a quadratic function in standard form, the first thing I want to make sure that you can do is determine and identify what the coefficients a, b, and c are. And then we need to find the vertex, because we need to know where is this graph located. And so we're going to do that by finding the opposite b over 2a. And then to find the y, well, remember f of x is the same as y, so to find the y we just have to plug that x value back into my original equation. Then I want you to draw and name the axis of symmetry. And remember, the axis of symmetry is a vertical line, so it's of the form x equals whatever the x-coordinate of the vertex is. Then I want you to determine 3 values on one side of the vertex. And then, of course, you're going to plug those back into the original function to evaluate it for the y values. Then I want you to plot those 3 values from the t-chart. And now using the axis of symmetry, I want you to plot the reflected points and then draw the parabola. So now let's go ahead and follow these steps and graph a problem. So negative x squared plus 6x minus 8. So first of all, my a is negative 1, my b is 6, and my c is negative 8. So I need to find the vertex. So the opposite of b over 2a is negative 6 over 2 times negative 1, and this is 3. So now to find the y-coordinate, I'm going to plug that back into the function. Negative of 3 squared plus 6 times 3 minus 8 gives us 1. So my vertex is at 3, 1. So I'm going to go ahead and plot that point. And then my axis of symmetry, since I've got my vertex, is x equals whatever that x coordinate is, so 3. And I can draw my axis of symmetry in. And now I could pick points for my t-chart, either 3 points to the left, so 2, 1, or 0, or I could pick for my t-chart 4, 5, and 6. So 3 points on one side or the other. It really doesn't matter. But for my t-chart, I pick the values on the left. And so when I plug in 2, I get 0. Plug in 1, I get negative 3. And plug in 0, I get negative 8. So plotting those 3 points. And now using the axis of symmetry, so for the first point, it's 1 unit over to the axis of symmetry. So I'm going to move 1 more unit over, and then 2 units over. So I'm using the axis of symmetry, and then I'm going to draw in my parabola. So the work that I want to make sure that you show, so we're clear about this, is I want you to show me your work to find your x-coordinate. And then either this step or this step, but I want you to show me your work, some of your work for your y-coordinate, and then tell me specifically what your vertex is. Tell me also what your axis of symmetry is, remembering that it is a vertical line, so it needs to have the form of x equals. I want to see your t-chart. I don't necessarily need to see that work. And then, of course, your graph. Okay, so now, where is the minimum or maximum value of a quadratic? Well, the minimum it would have if it has a lowest point, and a maximum would be a highest point. And so keep in mind that those occur if the quadratic opens up or it opens down. But in either case, it is the vertex. And most specifically, if I want to know how high something is going or how low something is going, I'm going to find the y-coordinate of the vertex. So now to tell whether the function has a minimum or maximum, I kind of jumped through this a little bit too fast. Let's get up here. Okay, first of all, 2 is positive, so therefore it tells me that it's going to open up, and therefore it's going to have a minimum value. And so then I need to find the value of that minimum value. So to find the y-coordinate, I must first find the x-coordinate. So when I go ahead and do this, I get the x is negative 1. Plugging that value into the function, doing the order of operations, I find that I get y is 1. So it's going to have a minimum value, because I determined that previously, of 1, the y-coordinate, at negative 1, the x-coordinate. And that would be my answer. And now we have the word problem. A video store sells about 150 DVDs a week at a price of $20 each. The owner estimates that for each dollar decrease in price, about 25 more DVDs will be sold. How can the owner maximize the weekly revenue? Well, first of all, do we know what revenue means? And in case you don't, revenue is basically the income. So how much income can the video store make from these DVDs? And so we're going to use the familiar model of price times the number sold. And so we're trying to find out how many times we should decrease the price. So that's how we're going to define our x, is the number of $1 decreases. And so again, we're going to use this familiar model of revenue equals the price times the number sold. Right now, we're selling them for $20 each, and at that price, we're selling about 150 a week. But we want to decrease the price, so we're going to subtract something from the price, and we're decreasing $1 each time. So it's minus $1 each time, but we have to determine how many times we're going to decrease the price, so times x. And each time we decrease the price, we're selling more DVDs. So we're adding to the number sold. How many? Well, we're adding 25 every time we decrease the price. So plus 25x. So now we're going to multiply this together using the familiar FOIL model. And we get 3,000 plus 500x minus 150x plus 25x squared. And now just combining like terms and writing this in standard form, I get y, or r of x, equals negative 25x squared plus 350x plus 3,000. And so what exactly does this mean? Well, it's negative 25x squared, so it's going to be a parabola opening down. But again, what does this mean? Well, keep in mind the vertex is the highest point, and in terms of an x and a y coordinate, my x is the number of times I'm going to decrease the price, and the vertex is the highest value that it's going to reach, so that's going to be the most revenue that I'm going to be able to make. So in order to find the maximum revenue that I want to make, I need to find the y coordinate of the vertex. Well, in order to do that, I need to find the x coordinate of the vertex. So using opposite b over 2a, I get that my x coordinate is 7. So to find out what my maximum revenue would be, my y coordinate, I need to plug that into the function, and I get 4,225. So my vertex is 7, 4,225. But again, what does this mean? How do we interpret this? Well, 7 is the number of $1 decreases, and 4,225 is the maximum revenue. So how much am I going to charge? Well, if I go back to my original model here, remember this is the price times the number sold. So this first one is the price that I'm going to charge. So if I plug my 7 from my vertex in there, I get 13. So my new price needs to be $13, and my maximum revenue, the y coordinate of my vertex, is $4,225. And again, if I use this whole function and plugged x7 in for that x and that x, I would get $4,225. So make sure you bring your questions to class if you have them. I know that there's a couple questions that I intentionally left unanswered, so try to answer those and we'll discuss those in class. And make sure that you go back and do the notes check. And we'll see you in class.